Hello, hello, are you able to hear me? Hello, hello. So I waited for long enough and I don't see that people are coming. So I will start with the week 3 session. Uh, I can see only one person has joined. So, hello, are you able to hear me? Hello, hello. Okay, then I will start with the week 3 session. So, hello everyone, whoever has joined. So I welcome you all to the third week session of the mathematical methods. So here I start. So this is the outline of the today's agenda. So as I promised last time, I will be first giving you a brief recap of what you have learned in the third week, and then we will be solving some problems based on the things you have learned, and those things will help you in solving the tutorials like assignments what you need to submit in order to do this course. So these are the things that you have learned. So let me just bring out my pointer. Yeah. So first you learn in this course the method of variation. So method of variation is used to solve the second order homogeneous differential equation which has constant or variable coefficients. And the second thing you have learned like how one can solve the differential equation using the change of dependent variable, where you can change the dependent variable depending on what type of differential equation is given, and then you can also change the independent variable. And the last thing you have learned is like in during your third week lectures is to solve the higher order homogeneous differential equation. So this thing I am not gonna cover in this tutorial because this is already like the extension of the uh, week 2 lectures, because here in order to solve the higher order differential equation same techniques are applicable as you have learned in the week 2 course. So we will be going through all of these topics starting from the method of variation to the change of dependent independent variable, and then we will solve some questions that will include all these four topics. So here I start with the method of variation. So yeah, so in the method of variation what you learn, so you learn like you can solve the second order homogeneous differential equation by another method which is called method of variation, and this method can be applicable to both like when you have the constant as well as the variable coefficients. So the equation you are given is of this type. So you have y double dash x plus fx times y dash plus gx times y is equal to rx, right? So in order to solve this differential equation by the method of variation, what you need to do, you first need to find the complementary function of the homogeneous part. So once you wrote the complementary equation, which is ycx is equal to c1 times y1x plus c2 times y2x, you can get like what are the y1 and y2 functions. And from that, what you can do, you can compute like what will be the Roskin of my these two functions. So Roskin can be, as you have studied earlier, Roskin can be computed in a very easy way by just w is equal to y1 y2, and then you take the derivative of above functions, so y1 dash and y2 dash, right? And similarly, after finding the complementary function, you need to find the, like what are the particular function of this homogeneous differential equation. So the particular function can be written as ux times y1x plus vx times y2x. You already know like what are the values of y1 and y2x. So the thing remain is to just to find the values of ux and vx. and after that you will be able to write the complete general equation of the given differential equation. So in order to calculate like what are ux and vx, what you need to do, you can calculate the ux by using this formula, where ux can be written as minus times integral of y2 times rx, where rx is the right hand side, and where y2 is on the right hand side, like rx is on the right hand side, so ux can be written as simply minus y2 rx upon w, where w is the Roskin, times dx. So you can simply write this expression and then you can integrate it just to find the value of ux. And similarly the value of vx can be found, so vx is just y1 times rx upon w times dx. So so the summary is, first you calculate like what are the complementary function of your homogeneous part, and then you just calculate like what are the ux and vx from the given differential equation, and then you can write the complete general solution of the given differential equation. So this is all about the method of variation. Later we will be going through some of the examples where I will show you how one can solve the differential equation using method of variation. Now the other thing what you have learned during your course is like how you can solve the differential equation by changing the dependent variable. So suppose you have some differential equation given in this form, y double dash plus py dash plus qy is equal to r. So here the dependent variable is y because you are defining the derivative with respect to x. So y is the dependent variable. Now what you do in this dependent variable thing, you first substitute value of y is equal to uv in the given differential equation, and by doing so what you can do, you can completely eliminate the first order derivative from the given differential equation, and you can reduce the equation to this normal form. This equation is called the normal form of the above differential equation, and from there you can see this equation is easy to solve. What you need to do now, you can find the value of I and value of s. So value of I is given by q minus half dp by dx minus p square by 4, and value of s can be written as r, where r is the right hand side function of the given differential equation, and then you have a exponential power half integral p dx. So if one can compute like I and S for the above differential equation, one can reduce the above differential equation in this normal form, and then this is easily solvable. We will be again using this dependent variable method in order to solve some differential equation. So the things will be much clear when I start the examples of all the methods. So the last method what you have learned is, now you can change the independent variable. So independent variable here is x. So what you do, you have given differential equation y double dash plus py dash plus qy is equal to r, and then you change the variable from x to z because x is an independent variable. Now by doing so what you can do, you can write the differential equation in this form, where you have d square y by dz square, because now you have replaced the dependent variable from x to z. Your derivative will be respect to z only. So d square y by dz square plus p1 dy by dz plus q1 y is equal to r1. So after just changing the variable, you can get this type of differential equation, and the various value of p1 q1 and r1 can be computed using these formulas. Now what one needs to do, one can do right now, one can actually put this q1 as a constant. So if one put q1 as a constant, so from there you already know like what is the value of q, and from there you can get like what will be my function z dependence on x. So once you get the z dependence on x, you can easily solve this differential equation. Again, we will be solving some example where we will be implementing this method in order to solve the differential equation. So okay, now what I will do, I will going through some of the problems where I tried to use all the above methods so that you can get a clear idea on how to use these methods. So here are the examples. So first I will be starting with the examples of method of variation. So as in assignment, you are given problems like where you need to calculate, solve the differential equation by using the method of variation or by using the change of dependent variable or change of independent variable. Similarly, here I have distributed the examples in 4 formats, where first I will be starting from the method of variation, then I will be solving some problems from the method of independent variable, and then from the method of dependent variable, and at last we will be solving some higher order differential equation, where we will be extending the uh, week 2 ideas of solving the differential equation. So let's start with the method of variation. So you are given this problem. So what you have d square minus d minus 2 times y is equal to e power x plus 3x. So what you need to do, you need to solve this differential equation by using the method of variation. So as I told earlier, so what one needs to do in order to solve this, first you need to compute or calculate like what are my complementary functions, right? So once you calculate the complementary function, you calculate the Roskin, then you calculate the particular function by writing u1 times y1 plus u2 times y2, and values of u1 and u2 can be computed from the formulas which I have shown. Okay, so let's go through the solution of this. So what you have on the left hand side d square minus d minus 2 times y, right? So you already know like how to solve the complementary function of the homogeneous differential equation. So what you do, you write the auxiliary equation, right? So auxiliary equation of this will be m square minus m minus 2 is equal to 0, right? And from there what you can get two values of m. So basically you have two unique and distinct roots. So when you have the unique and distinct root, the complementary function of the above differential equation can be written as c1 times e power minus x, because value of one root is 1, and then you can write c2 times e power 2x because the value of other root is 2. So this is a total complementary function, and from there you can write it as c1 times y1 plus c2 times y2, right? So now if we compare both the equation, one can write like y1 is equal to e power minus x. Similarly, you can write y2 is equal to e power times 2x, right? This is easy to solve, and this we have covered in the week 2 as well. So now, as I told you, what you need to do, you need to calculate like what is the Roskin of like above functions. So now you write y1, y2, and then y1 dash, y2 dash, right? So now we put the value of functions y1 and y2. So value of function y1 is e power minus x. Value of function of y2 is e power 2x, right? And now you take the derivative of above two functions. So derivative of e power minus x is minus power minus x, and derivative of e power 2x will be 2 times e power 2x. Now one can solve the determinant of this matrix. So after solving this, what we get? We get the Roskin of 3ex, right? So now you have calculated the Roskin. So now what remains? Now we need to solve like what are the values of u1 and u2, right? So as I told you, the value of u1 is minus times y2 times fx upon w, right? So y2 here is e power 2x, right? So basically you write y2 is equal to e power 2x, right? And then value of fx, which is on the right hand side, is e power x plus 3x, because that is what given in the equation, and then you divide it by the Roskin. So Roskin is 3ex, right? Now you can rewrite this equation. So what you have, you can expand this rx part, so you can write e power x times e power 3x, right? Now from here what you can do, you can again rewrite the equation. So you can bring this factor of 3 out from the integral, and you have e power 4x, because in numerator you have total power of 5x of exponential, and in denominator you have power of 3 just x. So the remainder is e power 4x, and then you have this e power x dx. Now the only thing is to solve this integral, and the idea behind to solve this integral is, what you do, you use method of substitution in order to solve this integral. So what you do, you put e power x is equal to t, right? So now you know, if I take the derivative on both sides, you have e power x dx is equal to t dt, uh, is equal to dt, right? And then from here what you can do, you can rewrite this equation in this form, right? You can rewrite this in this form. So basically now you have substitute this value of e power x dx here. So you have t cube times e power t times dt, right? And now it's very easy to solve this integral. What you need to do, you just need to take apply the like integration by parts 3 times in order to solve this integral. So here I have directly write like what will be the answer to this integral, but I urge you all to go through and solve this integral. It's very easy actually. So from here what you can write, it as minus 1 by 3 t cube e power t minus 3t square e power t plus 60 times e power t minus 60t, right? So from here you can easily write like what is the value of u1 here, right? And now what you can do, similarly you can write like what will be the value of u2. So u2 is a u2 comes with the plus sign as I stated before. So u2 is y1 times fx upon w times dx, right? So value of y1 you already know, that is e power minus x. And then similarly you can write like what is the value of fx given in the equation, and Roskin is 3 times e power x. So from here you can again rewrite this equation as e power minus x e power x times e power 3x upon 3x, right? So from here if you see what you have, if you calculate like what will be the remainder of exponential from the numerator and denominator, you will only left with the power of e power x times e power x dx. Now it's very easy to solve. You again use the method of substitution. So basically what you do you again write e power x is equal to t, and then e power x dx is equal to dt, and from there you can easily solve this integral. So the value of this integral will be e power x upon 3, right? So now you have both the value of u1 and u2. So basically the particular integral of this can be written as u1 times y1 plus u2 times y2, right? So you can basically club both this u1 and u2, and you can write your complete particular integral in this form. So now you have both the complementary function as well as the particular integral of the differential equation. So the general solution of this differential equation can be written as y is equal to cf plus pi. So cf is c1 e power minus x plus c2 e power 2x, and then pi is plus e power x upon 3 times 3ex minus 6 plus 6e minus x, right? So this is the solution of the first problem, and I hope you all got the idea like how to solve it. So I urge you all to go and solve this problem, because these type of problem are very easy. The only thing is you need to calculate the complementary function. Once you calculate the complementary function, then you only need to do the integrations to in order to find the solution of the differential equation. So again, this method of variation is just like you need to first find the complementary function. So once you get, you will be able to solve the problem. So this is all about the first problem. So now we will be starting from the with the second problem. So here you have this type of differential equation. So you have x square times the double derivative of y plus x times dy by dx minus y is equal to x. So again you need to solve this differential equation by using method of variation. So again what you need to do, you need to find like what are the complementary function of this equation. So once you get the complementary function, then the general solution is straightforward. So again let's go through the solution of this equation. So what you have, you can rewrite the equation in this form, where you can have d square y by dx square plus 1 by x times dy by dx minus 1 by x square times y is equal to 1 by x, right? So as you have studied in the method of reduction course, in order to calculate the complementary function, you can use that idea. So you say y is equal to xm is a complementary function if it satisfies this condition, right? This you have studied in the week 2 lectures, and if you don't know, then you can either go and see the lectures, or you can also go through the week 2 assignment where I have covered it thoroughly. So from here you see, if you put like from here you can compare like what is the value of p. So value of p is 1 by x and value of q is minus 1 by x square, right? So if I put in this y is equal to x power 1, so if I take value of 1, m is equal to 1, then what you have p, if p x plus q x square is 0 or p plus qx is 0, then y is equal to x is a complementary function. So if you put value of p and q from this given differential equation, you will see that both y1 is equal to x and y2 is equal to 1 by x are the complementary function of this equation, because if you take the value of m is equal to 1 or value of m is equal to minus 1, it both satisfies this condition. So basically what you have, you have two complementary function. So you have y1 is equal to x and then you have yt is equal to 1 by x. So as I told you, the idea is to just find the complementary function. Once you have it, it's very easy to solve the problem. So again, we can write the complementary function as c1 y1 plus c2 y2, where y1 is x and y2 is 1 by x. So you have a complementary function is equal to c1x plus c2 upon x, right? So now what you can do, you can again write the Roskin of this. So Roskin will be x times 1 by x, then the derivative of x will be 1 and derivative of 1 by x will be minus 1 by x square. So after solving this determinant, what you get? You get value of minus 2 by x. So now you have the value of y1, you have the value of y2, you have the value of Roskin, right? So now the thing remain is to just find the value of u1 and u2. So u1 again is given by minus y2 times the function which is on the right hand side upon Roskin times dx. So value of y2 from here is 1 by x, right? So you have 1 by x times 1 by x, because your function on the right hand side is also 1 by x, and the Roskin will be like minus 2 by x. So when you write in denominator minus 2 by x, x will come above and you also cancel the minus sign because it's appearing twice. So now what you can cancel the x in the numerator and denominator because x is not equal to 0. So what you left with? You are left with 1 by 2 times 1 by x dx, and like the integration of 1 by x dx is just log x. So value of u1 is just 1 by half log x, right? Now the value of u2, so value of u2 will be y1 times fx upon w times dx. So value of y1 is x, right? And the value of fx is 1 by x, and Roskin again you can write x by 2, and here comes the minus sign because there is a minus sign in the Roskin. So again you can see like you again cancel the x in numerator and denominator, so you are left with the integration of x by 2 dx, which is equal to minus x by square by 4. So now you have all the values. So the particular integral you can write u1 times y1 plus u2 times y2. So if you take half log x times x by 2, half log x times x, and then you have minus x square by 4 times 1 by x. So your particular integral will be like this. So now the general solution of the differential equation can be written as y is equal to complementary function plus particular integral. So complementary function is c1x plus c2 by x, and the particular integral is x by 2 log x minus x by 4. So this is again all about the second problem. Again, as I told you, first just calculate the complementary function and then it's very easy to solve the differential equation using the method of variation. So now I will come to the problem 3, which is again I have taken little different. So here what you have x square d square y by dx square minus 4x dy by dx plus 6y is equal to x square log x, right? So again, what you do, you again calculate like what are the complementary function of given differential equation. So here, if you think like, if you recall like what you learned in the week 2, so you realize like this is a Cauchy on the left hand side. This is a Cauchy-Euler equation, right? So you know like how to solve the Cauchy-Euler equation. So let's go through the solution. So as I told you, this is a Cauchy-Euler equation with variable coefficients because you have terms appearing like x square in the with the derivatives. So what you do in the Cauchy-Euler equation, you substitute x is equal to e power t, right? So now what you have, if you take the log on both sides, you have log x is equal to t, right? So from there, as we have studied earlier, the value of x times dy by dx can be written as dy, And similarly, the value of x square times the double derivative can be written as d times d minus 1y, and same can be extended for higher derivative also. But in the problem we have only like appearing till second derivative, so basically we substitute this value of this function as well as this function in the given differential equation. So what you have d times d minus 1, right, because you have x square d into d square y by dx square minus 4x dy by dx, right. So you have minus 4 times d, right, and then you have plus 6y, so y is taken outside, so you are left with d square minus 5d plus 6 times y is equal to, on right hand side if you see you have x squared log x, right. So x squared log x will be e power 2t times t, right, because you have substitute from by replace x by e power t, so you need to do the same substitution on the right hand side also. So now you are left with this equation, and now it's very easy. You see you have used the Cauchy-Euler equation, and here this equation appears to be like one can easily solve this. So like in order to solve this equation, in order to find the complementary function, what you do, you write the auxiliary equation. So auxiliary equation of this left hand side will be m minus 2 times m minus 3 is equal to 0, because m square minus 5m plus 6 can be written in this form, m minus 2 and m minus 3 is equal to 0, and from there what you can have two unique and distinct root. So you have value of m is equal to 2 and 3. So now the complementary function can be easily written as c1 times e power 2t, because one root is 2, and then you can have c2 times e power 3t because other root is 3. So now if you write it as c1 times y1 plus c2 times y2, the value of y1 is e power 2t, value of y2 is equal to e power 3t, right. Now what you do, you calculate the Roskin, right. So the Roskin will be e power 2t e power 3t, and then you take the derivative. So the derivative of e power 2t will be 2 times e power 2t, and value of e power 3t will be 3 times e power 3t. And if one solve the determinant of this, you will get like e power 5t. Now you have both the complementary functions as well as Roskin. You again calculate like what is the value of u1. So the value of u1 is minus y2 times ft, because now you have a function of t, not x, upon w times dt, because now the derivative is respect to t, not x, right. So keep that in mind. You need to uh, take care of this. So now you can write like y2 you have e power 3t, and value of ft is equal to t times e power 2t, right, and in the denominator you have e power 5t. So basically if you compare like the powers in numerator and denominator of the exponential, they both cancel each other, so you have minus integral of t times dt, right, and the integral of minus t times dt is nothing but minus t square by 2. So basically you can easily see like value of u1 is minus t square by 2, right. Similarly the value of ut can be calculated. So the value of u2 is y1 times ft upon w times dt. So value of y1 is again e power 2t, because value of y2 is e power 3t. So and ft is t times e power 2t, and then the denominator you have e power 5t, right. So again you see if you compare the power in numerator and denominator of the exponential, you have one more power in the denominator. So basically what you have t times e power minus t dt, and now again you apply integration by parts by taking the first function as t, and by taking the second function is e power minus t. You can easily solve this integral, and the value can be written like this. So you have u2 is equal to t times minus e power minus t minus e power minus t. So here which can be written in this form. So now you have both value of u1 u2, you have both value of y1 y2. You can write the particular integral in this form, where particular integral is u1 y1 plus u2 y2, and then you get this form of the particular integral. So you have minus et2 t times t square by 2 plus t plus 1, right. So now you have the value of particular integral, you have the value of complementary function. You can write the general solution as complementary function plus particular integral. So I hope like I covered these three problem, and I also covered like some portion of the week 2 where I use the Cauchy Euler equation as well as the method of reduction in order to solve the complementary functions of the differential equation. Okay, so this is all about the method of variation. Now what I will be doing, I will be solving one problem based on the change of dependent variable, and similarly some problem on change of independent variable. So let's start with the change of dependent variable. So you have the equation of this type. So you have y double dash minus 2 times 10x times y dash plus 5y is equal to e power x sec x, right? So as I told you, like this is a method, this is solved from the method of change of dependent variable. So the dependent variable here is y is equal to y. So as I told you, like what you do first, write y is equal to uv, and then you reduce the given differential equation into the normal form, and from there you can easily solve the differential equation. So let's go through the solution of this. So as I told you, first what you do, you write the value of p, q and r. So value of p, if you compare this differential equation, the value of p is minus 2 10x, value of q is 5, and value of r is e power x sec x, right? So what you need to do now, you need to calculate like what is the value of u, right? So value of u is e power minus half times p dx, right? So value of p is minus 2 10x. So from here you can easily calculate like what is the value of u. So value of u is sec x, and as I told you, like the normal form of the general differential equation can be written like this, where you can now calculate like what are the value of I and s. So value of I is given by q minus p square by 4 minus half dp by dx, as I told you before. So here q is 5 and p is minus 2 10x. So you have 5 minus 1 by 4 and square, and then you have 4 tan square x. So minus sign will dilute because here is a square appearing here in this equation, and then you have minus half dp by dx. So minus half times dp by dx. So dp by dx of tan x is sec x square x. So you have minus 2 sec x square x, and from here the value of I can be written as like 5 minus tan square x plus 1 plus tan square x, which is equal to 6, right? And now what you need to solve, you just need to solve like what is the value of s, right? So the value of s can be written as r by u. So here r is e power x sec x, right? And the value of u is sec x, which we computed earlier here. So the value of s is just e power x. So basically now you have all the ingredients of this normal form of the differential equation. So if I put all of this like value of I and s in the normal form of the differential equation, I will have this type of differential equation. So I have d square v by dx square plus 6 times v, right, because my I is 6, is equal to x, where s is e power x. So you have d square v by dx square plus 6v is equal to e power x, right? Or you can write this equation in this form, d square plus 6, where d is d over dx, plus 6 times v is equal to e power x, right? And now it's very easy again to solve this differential equation. So what you need to do, you again calculate like what is the auxiliary, what is the auxiliary equation of this differential equation. So auxiliary equation is given by m square plus 6 is equal to 0. So from here what you have value of m as value of m will have two complex roots. So when you have the complex roots, the complementary function is written as c1 times cos times the complex part, where complex part is root 6. So you have c1 times cos root 6x plus c2 times sin root 6x. So you see although this equation appears little different, but when you use the method of change of dependent variable, your equation can be written in this normal form, and this type of equation can be easily solvable. You just need to write like what are the auxiliary equation, you again write what are the complementary function. So once you have the complementary function, you write like what are the particular integral. So particular integral, as stated in the second week, particular integral is just right hand side function divided by the function of d. So here function of d is d square plus 6. So you have particular integral is equal to e power x upon d square plus 6. And as you have learned earlier, So in order to solve this function, what you have, you can simply write d as like this complete function f of d can be replaced by f of a, where a is the power of the exponential. So as here the power of the exponential is 1, so your particular integral will be e power x upon 7, right? So now the general equation will be u times v, right? So you have uh, this u is equal to sec x, and then you have value of v is equal to c1 cos root 6x plus c2 sin root 6x plus 1 by plus e power x upon 7. So this is the like how you solve this problem using the method of dependent variable. So again, it's a very easy problems. You just need to follow some protocols in order to solve these equations, and the point here is to make your given differential equation in such a way that it's easily solvable. So as again I am saying, like this equation was appearing little different, but once you use the method of change of dependent variable, this equation reduces to this form, and this type of differential equation you have already solved in the second week of the mathematical method course. So the again the general solution can be written in this form. So this is all about the about this problem. So now what I will do, I will again start one problem based on the method of change of independent variable. Okay, so as I stated earlier, you have this type of differential equation. So you have x times y double dash minus y dash plus 4x cube y is equal to x power 5. So if you just see this equation, we don't know like how to we have no shortcut methods in order to solve this equation. So that's why the question is asking you to solve the differential equation using the method of independent variable. So what you do in the method of independent variable, you replace your x by some z, right? So what you do, first you rewrite your equation in this form. So you have y double dash minus y dash upon x plus 4x square times y is equal to x power 4, right? So from here what you can do, you can extract like what are the value of p, what are the value of q, and what are the value of r. So value of p will be minus 1 by x, right? So value of q will be 4x square, and value of r will be x power 4. And as I told you earlier, you can rewrite by changing the variable from x to z, you can rewrite your equation in this form, where you have d square y by z dash square plus p1 dy by dz plus q1 y is equal to r1. And from here, as stated earlier, the value of p1, q1 and r1 are written in this form. This is also stated earlier. So and now after writing this equation, what as I told you, what you need to do, you need to make the value of q1 as a constant. So if you see here, the value of q is 4x square, right? So if I use this equation, like q1 is equal to 4x square upon dz by dx ka whole square, right? So here I can choose q1 as any constant, right? So what I do, I choose q1 is equal to 1 here. So if I choose q1 is equal to 1, then what I have dz by dx ka whole square is equal to 4x square, right? Because the value of q is 4x square. Now, if you solve this, you get dz by dx is equal to 2x, right? Which is easily solvable because there is a square on both sides which will get cancelled, and you will get dz by dx is equal to 2x. And from here you can easily integrate this equation, and you can get the value of z will be x square, right? Because x dx ka integration will be x square by 2, and there is already 2 appearing in the, as a coefficient, so you have value of z is equal to x square. Now once you have the value of z, what you need to do, you need to compute like what will the value of p1. So from the formula, value of p1 is d square z by dx square plus p dz by dx upon dz by dx ka whole square, right? So the value of d square z by dx square, if you double integrate this z function, what you will get, you get value of 2, right? Because the double derivative value with respect to z is 2. With respect to x, like double derivative of z with respect to x will be 2, and then the value of p is minus 1 by x as given in the problem. So you have 2 plus times minus 1 by x, and then you have just a single derivative. So single derivative is just 2x. So you have 2 plus minus 1 by x times 2x upon dz by dx का whole square, where dz by dx का whole square is just 4x square. So if you solve this, you see you get value of p1 is equal to 0, right? So now you have a value of p1, you have a value of q1 which is equal to 1, which we just assumed, and the value of r1 is r upon dz by dx ka whole square. So value of r from the given differential equation is x power 4, right? So you have x power 4 upon 4x square. So from here what you can see, the value of r1 is just x square by 4, and as you have changed the variable, you need to rewrite your function x function in terms of z. So here you see the value of z is x square. So basically the value of r1 is just z by 4. Now you have all the values of p1, q1, r1 that are given in this differential equation. So now you can rewrite your differential equation. So now if I rewrite this differential equation, you see you have removed basically the first order derivative, because the value of p1 is 0. So what you are left with, d square y by dz square plus q1 times y is equal to r1. So again the q1 value of q1 is 1. So what you have, d square y by dz square plus y is equal to r1. So you have d square plus 1 times y is equal to z by 4, right? Now again this is a very familiar equation. What you need to do, you again solve the homogeneous part. So you write the auxiliary equation. So you have m square plus 1 is equal to 0, and from there what you have, you again have the two complex roots. So now when you have the complex root, the complementary function can be written as c1 times uh, uh, cos z and c2 times sin z, because the complex part is 1. So you have just cos z and sin z, and z because the right hand side function is dependent on z, not on x. So you need to be careful while solving such type of a problem. Don't write it at like c1 cos x plus c2 cos x, because you have solved many problem where you have the independent variable as x. But in this given problem, like in the method of independent variable, as you are changing the independent variable, you also need to take care of writing the complementary function. So you have complementary function is equal to c1 is equal to cos z plus c2 sin z. Now you have solved the complementary part, right? So now what remains? Now you only need to solve like what is the particular integral. So particular integral of this such type of equation you have already studied. So the particular integral can be written as right hand side function, which is z by 4, and then you divide by the function of derivative. So function of derivative is d square plus 1, right? So you have d square plus 1 times z by 4, and now you have already solved such type of problems in the week 2. So what you do in order to solve such type of particular integral where you have some polynomial part, you basically write the function of derivative in terms of binomial expansion, right? So you take this 1 plus d square in the numerator by raising it to power minus 1, and then you can apply the binomial expansion. So if you now rewrite this in terms of binomial series, you have 1 minus d square and then some higher order terms and times z, right? So now what you are doing, you have 1 by 4 times z, right? So you will be z by 4, and then you need to take the double derivative of just z. So you know, like it's just a single function, so double derivative will be 0. So your particular integral is just given by z by 4, right? Now you have both the complementary function as well as the particular integral. Therefore the general solution can be written as complementary function plus particular integral. So the complementary function is c1 cos z plus c2 sin z, and the particular integral is given by z by 4, right? So one thing I want to mention, don't leave your problem by just writing in terms of variable z. The problem was given in terms of x. So what you need to do, you again need to replace the z by x when you rewrite the final answer. So just take care of that part. So this is all about this problem where we use the change of independent variable in order to solve the differential equation. So you see, like using all these three methods, uh, using all these three methods, you can easily reduce our differential equation in such a way that it is familiar to you to solve the differential equation. So I hope in like you can now easily solve your assignment if you get these type of problem, and also I tried to cover as much as I can in this tutorial. So here I covered the like three topics. Now what I will do, I will try to give you like 2-3 problems which we will solve using the same old methods which we studied in the week 2 lecture, but here we will be dealing with the higher order differential equation like of order 3, of order 4, and we will see how you can extend the week 2 lectures of finding the general solution for the higher order degree freedom differential equation as well. Okay, so here is the first problem. So as you see, you are given like d square plus d plus 1 ka whole square times d minus 2y is equal to 0, right? So as you see, you can see the uh, derivative appearing here uh, uh, are not of second order. So this involve higher order differential equation. So now we will see like how one can solve this equation by using the before methods. So again, this is a type of a higher order homogeneous differential equation, right? Because the right hand side is equal to 0. And you know, like what you do when you have a second order homogeneous differential equation, you just write what is the auxiliary equation. So same you do here for the higher order derivative also, or higher order differential equation. So what you have m square plus m plus 1 ka whole square times m minus 2 is equal to 0, right? That's how you write the auxiliary equation. So you have m square plus m plus 1 ka whole square times m minus 2y is equal to 0. And now if one solves like what are the root of this equation, so you have m is equal to 2, and then you have four more roots because this has the like this equation is a fifth degree, so it will have five roots, right? So you have one real root and other four roots are complex. Now you know if you have a real root, the complementary function is written as c1 times e power mx. So here m is 2, so you have c1 times e power 2x. And now you see like although you have four complex roots, but the given two roots are real and equal, although they are complex conjugate, but they are equal. And so now you can easily write like what is the complementary function when the roots are equal. So when the roots are equal, so what you have c2 plus c3x, right? Because two roots are equal, and the fact that these are complex as well, you will have the factors like cos root x and sin root x. Okay, so here I am writing the complementary function mapping with m is equal to 2s c1 times e power 2x. And now the fact that I have four complex root, but two of them are real and conjugate of each other, I will have e power minus x by 2 because the real part of all the roots are minus half. And the fact that both the two of the roots among these solution are equal, so I will have c2 plus c3x times cos root 3 by 2x because this is the complex part, and then I will again have c4 plus c5x times sin root x part. Okay, so you see it's like you are extending the week 2 lectures in order to solve these equations. So I think now you got the idea like how to solve differential equation even if you get some differential equation which are of higher orders. Okay, so this is all about this question. So now I will be moving forward and I will be dealing with the last question. So this will be the last question of the day. So here you are given, you have now a third order differential equation. So you have d cube y by dx cube plus 2 times d square y by dx square plus dy by dx is equal to e power 2x plus sine 2x, right? So again, you need to solve the general solution of this differential equation. So suppose you are given just the second order till second order. Suppose you are not given with the first order equation. So what you do in order to solve that equation, first you write the complementary function and then you calculate the particular integral and then you write the general solution which is cf plus pi. So same you do here. So if you try to find the complementary function of just the homogeneous part, right? So what you will have? You have m cube plus 2m square plus m is equal to 0, right? So you have m cube plus 2m square plus m is equal to 0. Now if you solve this auxiliary equation, what you have? You have m is equal to 0, m is equal to minus 1, m is equal to minus 1, right? So if you put all of three values in this, it will satisfy this auxiliary equation. Now you can simply write like what is the complementary function. So complementary function uh, uh, which is mapping to the value of m is equal to 0 is equal to c1 times e power m, where m is 0, so you are just left with constant. And the fact that
Sir,
yes,
sir,
yes, tell.
screen blank, sir.
What?
Your screen totally blank, sir.
Oh, I thought like,
Okay, now okay, sir.
okay, now it's maybe a connection problem. Sorry. Yeah.
Okay, okay, thanks.
Yeah. So the value of complementary function here can be easily written. So you have m is equal to 0. So you have c1 times e power 0, which is equal to 1. So your complementary function is just c1. And the fact that the other two roots are yeah, real and equal, you will have this factor c2x plus c3x, right? So the you have e power minus x because the value of m is equal to minus 1, and then you have c2 plus c3x. So here you can easily see like you can simply write the complementary function even if you are given some higher order differential equation, right? So now once you have calculated like what is the complementary function, you can calculate like what is the particular integral. So the particular integral, as you all know, can be written as right hand side function upon the function of d, right? So the right hand side function here is e power 2x plus sine 2x. So you have e power 2x plus sine 2x, and then you divide it by d cube plus 2d square plus d, because the derivative function here is d cube plus 2d square plus d. And now you see you can separate them. So you can write this as e power 2x upon function of fd. Similarly you have sine 2x upon function of fd. And now you know like how to solve when you have such type of particular integral. So you basically replace the d by factor of 2, because here you have e power ax, so a is 2, so simply you replace d by a. So you have 2 cube plus 2 times 2 square plus 2, and that comes out to be 18. So solving just the particular integral of this part, you have e power 2x divided by 18, right? Now you need to solve like what is the right hand side particular integral. So here you can see you have a sine 2x upon d cube plus 2d square plus d. So now what you have learned in the second week lectures, you can solve this particular integral by replacing d square with minus a. So here a is 2, so you need to replace d square by minus 2 ka whole square, right? But the fact that the function in the denominator is having a term like d cube, so what you can do, you can break this d cube by d square times d, right? And you know like how d square act on sine 2x. So you now what we can do, we can just simply replace d square by minus 4, right? Because a here is minus, here a here is 2, so d square will be replaced by minus 4. So now you have minus 4d because 1d you taken out, and then d square act on this sine 2x, so you are left with minus 4d. And then similarly you act this d square on sine 2x, so you have again d square is equal to minus 4, so you have minus 4d minus 8 plus d, right? Sine 2x. Now what you need to do, you know only like how d square act on sine 2x, right? So this we have already covered in previous tutorials. What you do in this case, you basically re-rationalize the denominator, right? So what you do, you know like the term appearing here is minus 3d minus 8, right? And minus sign can be taken out, so you are left with 3d plus 8. Now if you multiply the denominator and numerator by 3d minus 8, so what you are left with, you will get a power which is dependent on d square, right? And you know how to act d square on the sine 2x. So here what I have done, I have multiplied the denominator and numerator both by both 3D minus 8, because in the denominator 3D plus 8 term appeared. So if I do this, what I left with, minus, you have 9d square minus 64, right? So because 3d plus 8 times 3d minus 8 will be 9d square minus 64 times sine 2x, right? And now you again know how to apply like d square on sine 2x. So what you do, you again replace d square by minus 4. So you have minus 36 minus 64, that will be 100, minus 100, and then minus sign again will come here. So the final solution will be e power 2x upon 18 plus 1 by 100 times 3d minus 8 times sine 2x. Now when you apply like some derivative on sine 2x, what you need to do, you again need to take the derivative, because d is given by d over dx. So now if I again rewrite this, you again have e power 2x upon 18, and then you have 1 by 100, and then you take the derivative of sine 2x. So the derivative of sine 2x will be 2 times cos 2x. So 3 is already here, so you have 6 times cos 2x, right? And then you have minus 8 times sine 2x. So the complete particular integral of this equation can be written as e power 2x upon 18 plus 1 by 100 6 cos 2x minus 8 sin 2x. Now what you have both the complementary function as well as the particular integral. Those, so the general solution can be written in this form. So you see like how although it's a third order differential equation, but such problem can be easily solvable by using the former method which you have learned during your course. So even if you get some fourth order or fifth order differential equation, you can extend the week 2 lectures like what you have what you have learned there in order to solve even the higher order differential equation. So I hope uh, I was clear enough to give you a general idea of like what you have done in the week 3 lectures by going through all the concepts which you have learned, and also I tried to solve at least a one problem from the same concepts, and also I tried to cover most of the week 2 lectures also, because once you applied the all these methods like method of variation or dependent variable or independent variable, you are left with a second order homogeneous differential equation, and then in order to solve this you again need to use the tools which you have learned in the week 2 lectures. So okay, this is all about the today's tutorial. So I will urge you all to like solve this problem by yourself, and then you can also try to solve the assignment problem as well. And I hope you will be able to solve them now, because most like 2 3 problems I have solved here are from the assignment only. And also I will urge you all to please come on time. So today I see like people coming around 7:30, so it's very hard for me to stop in between and explain again. So please be punctual on time. So okay, then I thank you all to be the part of this lecture. So thank you. This is all about the week 3 assignment. We will be again meeting in the fourth week assignment. Okay.